All right, so I know that in the past I've made a lot of music before, but I've decided to perhaps switch my content. I am currently entering college for mathematics, so I think it would be fitting for me to maybe release a few videos on mathematics. And right now I'm just planning on giving you a brief overview of what I plan on doing. So, the field of math that I'm most interested in is called differential geometry. You know what? Let's make that differential geometry. And essentially, what this is a field that uses the properties of calculus to analyze geometric properties of things called manifolds, which are like surfaces or curves or three-dimensional spaces. There are some additional qualities that manifolds all have, but we'll get to that when we get to that. So I plan on releasing four different parts, um, each containing multiple videos. So, and each part will essentially serve as like a mini course, as like something that you would watch uh, for college uh, to help with college classes. So the first part will be an introduction to differential geometry. And the book that I'm going to be modeling my videos off of is Christopher Tapp's Differential Geometry of Curves and Surfaces. Now, I learned the equivalent content from a book called uh, Do Carmo, Differential Geometry of Curves and Surfaces. Same, the author is Do Carmo. Uh, but I feel like Tapp's treatment of the material is more modern and it's easier to read if you're following along. So that's why I recommend this book. So, of course, this book covers curves, this book covers surfaces, and then this book covers a little bit about curvature, Gauss curvature, normal curvature, mean curvature, principal curvatures, geodesic curvatures. Speaking of that, geodesics, um, and of course, a covariant derivative as well, and Gauss-Bonnet theorem. So after we do this, this is probably going to be about 30 videos approximately, give or take. I haven't planned them out yet, but after that, I'm planning on releasing a little bit of a series on topology. And the reason why is because I feel like topology is very deeply connected to differential geometry. So as we progress through the parts, we're going to need to know a little bit about topology as well. So the book I've selected is John Lee's Introduction to Topological Manifolds. Of course, the book that everyone would recommend when it comes to introductory topology is Monkrez's Topology. But I feel like Lee's treatment of topology is more well suited for the differential geometer, as Lee actually wrote three books meant to be read in succession to each other: topological manifolds, smooth manifolds, and Riemannian manifolds. We'll see one of them later. So what would this book cover? It would cover topological spaces. It would cover connectedness and compactness. These are terms you've probably heard in your everyday life, but like, I don't know, something is connected to, but we want to make these words mathematically rigorous in topology. What else? The fundamental group, which um, helps us categorize topological spaces. And we will also take a look at homology. Oh, I forgot. This will also be about 30 videos. Part 3 will be differential geometry in earnest, not just an introduction. And we'll learn a little bit about manifolds. So, of course, I chose Jeffrey Lee's Manifolds and Differential Geometry. I will not be going over all of the contents in this book. I will only be going over the first 10 chapters. Um, there's a lot of content in this book. Um, there are also a couple other alternatives, great alternatives. Um, John Lee's Introduction to Smooth Manifolds, written by the same John Lee as this one, this book. And Spivak's A Comprehensive Introduction to Differential Geometry, Volume 1 is always a good choice as well. But I'm going to be using Jeffrey Lee because I feel like the topics he selected, I mean, there's a lot of them. And the other Lee book has a lot too, but I have a hard copy of this one, so what can we expect to cover here? Of course, we'll be looking at manifolds. We'll be looking at tangent spaces. We'll be looking at vector bundles and fiber bundles as well. Tensors. Differential forms, and of course Stokes' theorem and de Rham cohomology. So that's a lot of content. So I'm gonna say about maybe 60 videos for this one. And then part 4 is a treatment on Riemannian geometry. And the book I'm using is another John Lee book, Introduction to Riemannian Manifolds. I learned Riemannian geometry from Joe Carmo's Riemannian geometry, but I feel like John Lee's book is a little bit more comprehensive and it is more modern. Joe Carmo's book is very old and it has minimal prerequisites too, so that makes it good if you want to go, straight from part 1 to part 4, but I think it's better to build up some of the mathematical machinery in parts 2 and 3 just to gain some understanding, deeper understanding. Let me write down Riemannian geometry. So we will be covering things like connections, like they look like this. And they basically tell us relationships between tangent vectors. And furthermore, more importantly, they can tell us how vector fields can be quote unquote differentiated through covariant derivative. We'll be looking at things like, we'll be looking at more of geodesics, except this time we won't be just looking at them in terms of curves and surfaces. We'll be looking at them in terms of manifolds in general. We'll also be returning to curvature, Jacobi fields, and manifolds of positive, zero, negative curvature. There are plenty of other great topics in Riemannian geometry. I know Do Carmo has actually some contents that I don't think Lee devotes a lot of uh, space to, but whatever. So, anyways, that's my plan for. Um, oh, and also 30 videos, maybe more. I might choose to do more because this subject is particularly difficult. Yeah, you can see they go in increasing difficulty, but I think this is an exciting project to undertake. Um, so let me know if you have any questions, and can't wait to start the first video, maybe in the span of a few days, something like that. So that's all I have for today.